Hello and Assalamu alaikum. My name is Mariam Shabina Ahmad. I am from the University Putra, Malaysia. I'm a PhD student and will be presenting the paper under the title Statistical Optimization Using Single and Co-Culture of Alkali Gene and Ceraceae to Degrade Used Cooking Oil. In my research committee, I've got Dr. Mohammed Tamizi, Professor Muhammad Yunus, and Dr. Aklima Ahmed from the University Putra, Malaysia. Before I start with my presentation, I would like to give an overview of my presentation. I would be having a short introduction followed by literature review, research problem, research hypothesis, objective, materials and methodology, results discussion for a conclusion followed by references. This slide represents the snapshot of the current situation. As you can see from the left-hand side, there is a lot of rapid urbanization which is happening, and simultaneously, industrial activities are increasing, and the eating pattern of people is changing from indigenous food to fast food. With these activities, there's an increased utilization of the cooking oil. With that, there's a generation of a greater waste into the environment. So this is the situation at the moment. If you look at the literature, it is estimated that in 2013 and 14, there was 130 metric tons utilization of the vegetable oil consumption. However, in 2021, there was 200 metric tons utilization of the vegetable oil consumption globally. Cooking oil is considered to be one of the essential ingredients in preparation of food all over the world. Global increase has generated a large amount of used cooking oil, which has created serious anthropogenic environmental risks that threaten the terrestrial and aquatic organism. The mismanagement of this particular world waste has led to a variety of cascading problems. Thus, this type of environmental pollution is considered to be a major problem globally. The population management policy strategies and intervention are to reduce the detrimental impact on the global health through evidence-based scientific mechanism. In this study, we use oleophilic microorganisms which are able to degrade oil. There are several microorganisms which are able to degrade the oil. However, the single isolates are known to have limitations in degradation. Co-culture can enhance the performance by synergistic effect and provide a better result by addressing the limitation. Hence, here we used single isolates of alkali gene and ceraceae in combination to see the used cooking oil degradation. Research hypothesis. In this study, the synergistic degradation of the used cooking oil is better than single bacterial isolates. There are two objectives in this studies, which is to characterize the ability to degrade the used cooking oil by single bacterial isolate and co-culture using one factor at a time, and to investigate the single and the synergistic effect on the degradation of cooking oil using response surface methodology. The method which was followed, shown in this slide, as you can see, we got the isolate from the Eco-Remediation Technology Laboratory, University Putra, Malaysia. Once we got the isolate, we acclimatized it, proceeded with the optimization using one factor at a time and response surface methodology. Results and discussion. To characterize the ability of the isolate, first we proceeded the incubation of the isolate. We conducted the study of degradation from day 1 to day 14 and observed that the maximum degradation was obtained on day 17. So in this experiment, the isolates were, the single and the co-culture were isolated for 7 days to see its degradation and bacterial growth. In order to proceed with the OFAC factors, the first parameter which we conducted the OFAC was temperature. It was seen that the bacteria perform best in between the range of 25 to 45 degrees, suggesting that this is a mesophilic bacteria. Beyond the 45 degrees, there was a declination of the degradation observed. As for the agitation, the optimum agitation speed for the single isolates were 150 RPM, and for the co-culture was 200 RPM. The effect of used cooking oil concentration indicated that the 3% was optimum for the single isolate and 2% was optimum for the co-culture. The best source of nitrogen was observed to be ammonium sulfate, and it is also a cheap source of nitrogen. Hence, when we proceeded with the use of ammonium sulfate in the subsequent experiment. pH. As for the pH, it indicated that the pH 7 was the optimum for both the single and co-culture isolate in this experiment. For the alkali there was 72.74% degradation observed in this pH. As for the Ceratacea, it was 79.3% observed, and for the co-culture, there was 72.40% of degradation observed under this pH 7. The optimum yeast extract concentration was 0.4 gram per liter for both the single and co-culture. As for the inoculum size, for the alkali gene, it was 6%, for Ceratacea, it was 4%, and for the co-culture, it was 8%. This slide summarizes the optimum, summarizes the OFAC and OFAC result for the single and co-culture isolates in this study. As you can see, alkali gene has 40 degree as temperature. Ceratacea has, and Ceratacea and co-culture has 30 degrees. Agitation was 150. Oil substrate was 2% and 3% and 2%. Ammonium sulfate was the best source of nitrogen. pH was the best pH. Yeast extract was 0.4 gram per liter, and inoculum size was 6, 4, and 8%. Then we proceeded with the next stage of experiment based on the 7 factors. We look into the parameters which is to be proceeded using the Plunkett-Berman design, and 5 parameters was used in this design to see what are the significant factors from this 5. As you can see, the 5 factors were pH, oil, temperature, yeast, concentration, and ammonium sulfate. The analysis of variance of ANOVA from the PBD illustrated that the parameter significant from PBD for alkali gene was pH, oil concentration, and ammonium sulfate, and all 5 factors were significant for Ceratacea and co-culture. The significance of the parameter is based on the p-value, correlation coefficient, which is the R-square value. This is quite in reasonable agreement with the adjusted R-square value. The closer the R-square value is to 1, the better the accuracy of the model. This slide illustrates the 3D image describing the pairwise interaction between the factors and its degradation. The image A and B is the result for the core culture, which indicates that there was 88.87% of degradation in image A and 86.93% for image B, and for alkali gene, which is the C, gives a 76.54% degradation, and for Ceratacea, it gives 65.3% degradation. The experimental results was validated, and validation indicated that the results were 98 to 99% accurate, and there was no significant difference between the expected and the experimental result based on the p-value which was obtained. Hence, the result is has 99% accuracy rate. Conclusion of this study indicated that the optimized condition identified via OFAC for alkali genes revealed a 68% degradation, and as for through RSM, it gave 76.31% degradation of oil. As for Ceratacea, it gave 62.69% through OFAC and 65.67% through RSM by CCD analysis. Optimized condition by OFAC for co-culture increased the oil degradation to 75.67%, while the RSM further enhanced the degradation by 89.16%. Thus, the study indicates the synergistic growth of the isolates perform better than the single isolate in the degradation of used cooking oil in this study. These are some references, and that's all for the for this presentation. If you have any question, all the questions are welcome. Thank you very much.